Have you ever wondered why ocean currents move the way they do? Why do some currents flow fast while others slow down? The answer lies in one of the most fundamental principles of fluid dynamics, Bernoulli's principle. Today we'll explore how pressure, velocity, and energy shape the motion of ocean currents and influence everything from climate to marine life. Bernoulli's principle states that as the velocity of a fluid increases, its pressure decreases. This is the same principle that explains how airplanes fly. But did you know it also governs ocean currents? Imagine water flowing through a narrow pipe. It speeds up where the pipe is tight but slows down where the pipe widens. The same thing happens in the ocean when water moves through narrow passages or encounters different pressures. Ocean currents don't just flow randomly, they follow the rules of fluid dynamics. Let's break it down. How Bernoulli's principle affects ocean currents. Pressure differences. High pressure zones push water toward low pressure zones, creating movement. Narrow passages, Venturi Effect. Currents accelerate when squeezed between islands or seamounts, just like water in a narrow pipe. Changing depths. As water flows over underwater ridges, its velocity and pressure shift, altering current speeds. Real-world example, the Agulhas current, South Africa, speeds up dramatically when squeezed between Madagascar and Africa, just like a nozzle directing water flow. According to Bernoulli's equation, the total energy of a fluid remains constant. It's just converted between kinetic energy, which is motion, and pressure energy. So, when ocean water speeds up, its pressure decreases, and vice versa. The key equation here is P plus 1/2 rho v squared plus rho gh equals constant, where P is pressure, rho is the density of water, v is velocity, and h is height, or potential energy. For example, as the Gulf Stream moves toward Europe, it slows down. This increases its pressure and helps to moderate European climates. While Bernoulli's principle is key, other forces also shape ocean currents. The Coriolis effect. Earth's rotation deflects currents, making them curve to the right in the northern hemisphere and to the left in the southern hemisphere. Wind patterns also play a role. Surface currents, like the Gulf Stream, are driven by wind. And let's not forget thermohaline circulation. Salinity and temperature differences drive deep ocean currents. Understanding ocean currents isn't just theoretical. It affects global climate, marine ecosystems, and even human industries like shipping and fishing. Warm and cold currents regulate global temperatures, which is crucial for climate control. Marine ecosystems are also influenced as fish migrate with currents affecting global fisheries. Extreme weather events, such as hurricanes, gain strength from warm ocean currents. For example, without the Gulf Stream, much of Europe would be as cold as Canada. To sum up, Bernoulli's principle helps explain why ocean currents move the way they do. Pressure differences, velocity changes, and conservation of energy all play a role. Next time you see an ocean current map, you'll know the physics behind it. Which ocean current fascinates you the most? Drop a comment below. Don't forget to like, share, and subscribe for more ocean physics videos.